In this video, I will discuss the relation between mechanical oscillations and electrical oscillations. Here we have a mass spring system where a mass M is attached to a spring whose spring constant is K. This mass is at its equilibrium position. When this mass is at a displacement x from the equilibrium position, we can write the restoring force acting on this mass by using Hooke's law as F is equal to minus kx. By using Newton's second law, we can write this equation as ma is equal to minus kx, and writing the acceleration in terms of the double derivative of position, we can write this equation as d2x over dt square plus k over mx is equal to 0. This is the equation which completely describes this mass spring system. Now we have an electric circuit in which an inductor of inductance L and a capacitor of capacitance C is attached. A current I is flowing through it. By using Kirchhoff's second rule, we can write the potential dissipation in this circuit as minus L di divided by dt and minus q over c is equal to 0. First term is the potential dissipation across inductor, while the second term is the potential dissipation across capacitor. Here we will use the fact that current is the single derivative of charge with respect to time, that is I is equal to dq over dt. When we put this in the above equation and a little simplify it, then our final equation will become as the double derivative of charge with respect to time plus 1 over LC time Q equal to 0. This is the second order equation which describes completely this electric circuit. Now these two equations have exactly the similar form. We can compare these two equations to calculate the mechanical and electrical analogues in oscillation. For example, here the displacement of the particle corresponds to the electric charge. That is, displacement and electric charge are analogous. Next, as current is the rate of change of charge, so velocity corresponds to the electric current. And the next is mass, which is dividing here, is simply corresponds to the inductance of the inductor, that is mass is similar to the inductance, and the role played by spring constant K in mechanical oscillation will be played by the inverse of capacitance in the electric oscillation. So these are the analogies between the quantities in electrical oscillations and in the mechanical oscillations.